Okay, we'll get started, okay? Already 3 o'clock. So this course, we are on the topic of project-based. And then the first topic we talk about is the mapping, the dictionary, the hash table, right? We talk about the first hash table, and then how they got implemented, and the hash function and how creation. And then second talk, we talk about this one, the tokenization. Okay, and the tokenization, we give you a finite state machine, okay? A simple finite state machine. But we can build more harder, bigger finite state machine, and then process more difficult tokenization problem, okay? And then right here in chapter 3, in the textbook, there is an example of the balance of the parentheses, also the increase post-fixed expression conversion. We'll talk about this, okay? We'll talk about this for the step. So right here, we go back to the topic of the tokenization, okay? And then about tokenization, first we would like to talk about let's see here. No, that is one. Soon is on regular expression. Okay. So first we would like to talk about the tokenization. So the purpose of the tokenization is very important because every program of your program, usually you have a program. Then you have some input, right? And you have some output. Okay, in the AP or the high school level, we just teach you, you enter a line by line. So you use a next line function in Java, okay? Or character by character. Or in Java, you have the next function that will provide token for you. But the token in Java will be A, B, C, space, A, B, C, and then change line. So basically, the token will be generated only separated by space and change line mark. So next function create a token. But if you have an A, B, C, comma, this comma will be considered to be part of the word. Okay. And then that's the tokenization you have in the Java, and you use the next function. Okay. In C++ similar, you would have similar get line, get s, get string. Okay, those different functions. And get character in C++. So it doesn't give you the right type of the tokenization you want to have. So last time we used the finite state machine. Okay, so finite state machine's purpose is to you actually have an input. You have an input buffer. So your character go in. Okay, so you see one character by a character. So if this one is state by state, you see a number, you go to the state one. It's state 0. Okay, and then if it's a number again, you stay in the state. If it's a number, Okay, if anything else, you will you will actually stay in the state. Okay. I'm sorry, if this is the space, you will stay in the state. If anything else, you will go to the stage 3 and it is wrong. Okay, so this anything else. So this one is number, and if it is non-number. So in stage 1, if you see a non-number, you will also get to stage 3. And stage 3 means you have error. So basically, anything comes with the continuous number, you will stay in the state 1. And then once you finish, you have a space, you go back to a space or change line. Here, change line also, you will stay in the same state. So you have a space or change line, you go back to your state 0. That's the standby state. Okay. So that's the simple finite states machine we had last week. Okay, so but the finite state machine can be more complicated, and how you can design your finite state machine, or how can you do the tokenization more efficiently? That is the question. Okay, that is the question. So go back to the textbook. Go back to the textbook. The textbook actually start to process the parentheses and talk about infix and postfix expression that would actually process the number and the parentheses. So before you do that, you would do tokenization. Create tokens. So this one is left parenthesis. This one is right parenthesis. This one is a number. This one is an operator. This one is a number. So basically, you will create token in a vector. And also a vector of token types. Okay, and besides that, you will go into the processing of the text and then convert the structure of the token. So converting the structure of the token, if you including the language model, LLM, then that become an AI problem. So right here, we may only talking about how to convert it in mathematical model. Then it is a compiler. If it is become the large language model that convert it into tokens, for example, like the we, go, home, and your token type, this one is subject. This one is a verb. This home is subject, object. It is also a nouns. Okay, this is using large language model and convert it into tokens. And each token has the token type and token type and token weight associated with it. And then you do best AI estimation that would do conversion for you, even translate among the different languages. Okay, but right now we do not go that far for those kind of the LLM token generation. Okay, we'll talk about expression and the stack. So this chapter is very, very important. Okay, it's very, very important for data structure. It's very important. So basically, first thing is that we would like to detect something. Okay, first one is the balance parentheses. Balance parentheses that balance including the the grammar, okay, they just want to do the balance or the expression. So basically, you see a expression left parenthesis, you also need to have a one right parenthesis in order to make sure this one is paired. Okay. So one way you can deal with it is that whenever you have a left parenthesis, you put it into a step. Okay. And then if you see a right one, you pop it out. Okay. So if you try to pop out something, you see a left one, but you try to pop out, but there is nothing inside to pop out, then you consider that is an error. Because that means there's a left parenthesis, but there's no right parenthesis. Is that okay? There's no right parenthesis. I'm sorry, there's a right parenthesis, but there's no left parenthesis. So that will create error. Okay. If you have more of the right than the left, then when your left pop out something, your right cannot see it. Your left don't have it, then you are in trouble. Okay. So if you only have your left, but you do not have the right, then at the end of the whole program, you should have more right, left, not pop out. So your stack is non-empty. And then you will say that, okay, this actually is non-empty. And then you will say that it's not balanced. So you can use stack, and you also can use a counter for this one. Okay, so let's look at this balance parenthesis. Okay, so this one I'm going to open a new folder. So I'm going to call it lecture 4, okay? So this lecture 4, we'll call it regular expression, okay? Okay, the first program we will write is balance parenthesis, okay? Okay, so you enter your string into A, okay, and A had all the character that you want to have, okay? Now you want to analyze whether A is balanced or not. So we will have a function called okay. So first one, let's use counter, okay? This counter, let's call it a different name. Don't call it C, call it level. Okay, so AI's character, let's call it C, okay? If you see a left parenthesis, then your level increase, okay? Okay. Okay. So if you see a right parenthesis, then your level decreased. If your level actually less than 0 in the middle of the process, any point in the middle of the process, your level is less than 0, means you have more right parentheses than the left parentheses, then you will return false. Okay. Okay. And at the end of the process, you return level equals 0. Okay. And sure. Okay. Make sure that. Okay, so you have an A, then we would like to create a Boolean. Okay. Okay, so this will give you the result whether it's balanced or not. Okay. This is a simple program, but let's run it. Okay. The level 1, most simple one. Okay, so this is balanced. Let's have more of the left side. So it's not balanced. I'm sorry, more of the right side is unbalanced. So that has more of the left side. It's also unbalanced. So this is a simple program can be used to process the balance of the parentheses. Left, you actually increase the level. Right, you decrease the level. So in the middle of the process, if you're right less than 0, then you will return false. And then overall, you need to make sure when you finish the whole thing, your level need to return to 0. Otherwise, you have more left parentheses. Okay, this one is a simple balanced. Any questions so far? You can also use a step to do push pop for it. Okay, you can also use a simple step to push up it. And in the middle of the process, if the step got pop out, but there's nothing in the step, then you will return false. Okay. So anyway, right here we talk about the balance of expression. But next one we are going to, and this actually is just the step 1 for the tokenization. Okay. Step 2 is that we may want to look into the conversion of the infix and postfix. So this one, first you need to know about, you need to do tokenization. Okay, so you got these. This is infix. Infix means your operator is in the middle. Okay, and then you want to convert it to postfix. So your A plus B will be converted to plus AB. Okay, this is in prefix. Okay, prefix means your operator is in the front. And then you will times C. Times C means you start in front of this one and this one. So you become star plus A, B, and C. Okay, so far, this is called prefix. Any questions so far? Next one is called postfix. Postfix means that your operator is at the end. So your A plus B converted to AB plus. And then your C is after it. So your AB plus times C, so your AB plus C and then start. This is called postfix. Okay. Any questions so far? So this is the so-called postfix and infix. Okay. And usually you have a calculator. So calculator usually is using postfix. Okay. Especially the HP calculator. HP's old days calculator is using postfix. So sometimes the postfix also called HP expression. It is also called reverse Polish notation. Okay, it was used in the HP calculator before. So you press the A, you press enter, you press the B, you press enter, and then you time. Okay, basically, when you do the operation, it is A and then B and then times. This is called postfix. Okay, this is called postfix calculator. Postfix calculator was popular for quite a while until recently. The more smarter calculator all converted to infix. Okay, so the relationship of postfix calculator and infix calculator is that you have the string first. And you convert it to tokens. This part we call it tokenization. And then token being this one, we also call it infix. and then we convert it to the postscript. And then we evaluate the value in the postscript. Is that okay so far? So this is why we want to bring up the tokenization issue, and then also would actually process the infix and postfix. Okay, because it's very important. A lot of your operation is at least the calculator language is processed by this infix and postfix. Okay, and then it's actually starting from the tokenization, then you go into the infix format, and infix being converted to postfix. So this whole chapter 3 is on this kind of the infix postfix and evaluation of expression. Okay, they are on these, and also talking about how to use a step to operate them. Okay, how to use step to operate them, and how you do evaluation for the programs. Okay, we are not going into the program yet. Okay, so we will basically first talking about the tokenization. So before we talk about tokenization, we'll talk about the regular expression first. So what is regular expression? Okay, what is regular expression? Regular expression is a kind of the grammar that the grammar rule that you use to find your tokens. Okay. A typical grammar is this called regular expression. Okay. So regular expression using the regular language. And regular expression is to find the patterns that matching certain string or pieces of strings in your token, in your lines. For example, how could you identify 2.34 as a real number? How did you identify 45 as an integer? Okay, then you need to write regular expression. So basically, this 45 is that you must have the first digit of 1 to 9, and then followed by 0 to 9. And the 0 to 9 can be infinity number. So you can use 1 to 9 and 0 to 9, and then 0 or more as an example. This one to describe that is an integer. Okay, that will be an integer. Any questions so far? And then if you talk about a digit including 0, okay? Natural number, there's no starting 0. So that's like that, okay? And then real number, the digit you can be a 0, or you can be a natural number. Okay, so this whole thing is an integer. And you write down as that's as this is defined as a natural number. So it's a natural number or 0. Okay, that will be your integer. Next one is real number. Real number written down as 2.34. That actually is a decimal point over there. Before that, you may have a number. That number is a natural number or a zero. And it followed by nothing or also a zero or natural number. Okay, so this is the regular equation. We call it syntax diagram. And last week we talked about the syntax diagram, okay? But right here, we are going to look at the regular expression. So basically, regular expression is a language to talk about the syntax diagram, okay? So first thing is that or, if you see a bar or, so or take the gray or gray. So left side or right side is the value token. If you just write a hello, that's a hello token, okay? That's the pattern you look at, is a single hello token. Then if you have the GR parenthesis A or E, and then Y, parenthesis used for grouping, okay? So this one really is a G followed by a R, followed by A or E, followed by a Y. Okay, so this pattern including gray or gray. You can also write down as a bracket of AE, that means that A or E, it is also A or E, okay? Or you can also write down A to E. Okay, then this is not A or E, this is A, B, C, D, E, it's called A to E. Or you can also write down A, E, I, O, U. A, E, I, O, U is any of the A, E, I, O, U later. So bracket is a set. Anyone in the set would be used. Any questions so far? Hello? Any questions so far?
No.
So you can also look at, okay, so this talk about bar is or, parenthesis is a grouping, and then this is actually a set, okay? And then question mark is one or more. Question mark means 0 or 1, I'm sorry, 0 or 1. So you have a car, L-O-R or L-O-U-R. This U have a question mark. That's U is 0 or more, 0 or 1. Can be 0 U or 1 U. Okay. So let's look at the next one. It's called regular is X. So this is E or ES is a group. So the ES is grouping, but it's a 0 or 1. So it's regular, is actually called regular. Okay, then you have the X, it followed by X. So you followed by X, and then ES or no ES. Okay, or XPS or no SPS. So this is the chart, okay? So this one give you registers, okay, that is with the X and nothing. And then with ES, okay, or with P, with SP, okay, or with SPS, okay? Is that okay so far? Right-hand side is the possible patterns matching the existing of that, okay? Left-hand side is the regular expression. Regular expression sometimes are written down as a regex. Okay. So it's very important that you try to understand how you can use vector expression to match your programs. Okay. And then when your string come in, you can grab this one as one number, grab this one as a one real number, grab the parentheses, grab the right parentheses, grab the operator plus. Okay, but before we go into the grammar or detailed analysis, first you need to be able to analyze the grammar. Okay, so question mark is 0 or 1. Star means 0 or 0 plus. Can be 0, can be 1, can be infinity. Star means, so it's a G and no O, or G with 1 O, or 2 O, or 3 O, or infinity number of O. Okay. O plus sign means one or more. Can be 1, single O, 2 O, 3 O, 4 O. Okay, it's 1 or more. Okay. So this one Google, this one OOG. OOG means that OOG will be 1 or more OOG. So it's Google or Google. Okay. 1 or more G. Any questions so far? So this one let me copy for you. Okay, this is the grammar of the vector expression. And by the way, this one is from the Loyola Marymount University. Okay, one university located in Los Angeles, not a bad university. Okay. And the next one is your quantifier. You can put G and then curly braces 3. That means that G repeat for 3 times. And then G and then 3, 6. That would be 3 times, 4 times, 5 times, to up to 6 times. Okay. Any questions so far? So G comma nothing, that is 3 plus 3 to infinity. Okay. So this is quantifier. Okay. This part we call it quantifier. Okay, this part we call it quantifier. Okay, next one you can have F star slash star slash star. So when you need to use a star, you use a slash star. Because star means 0 or more, but you just want to use a star, then that star need to have a escape sequence. So you use a backslash star. Okay. If it's a number, we use backslash D, that's the number 0 to 9 number. So your natural number can also be written down as 0 to 9, followed by backslash D star. Backslash D star means 0 or more digits. Okay. Any questions so far? So this is regular expression, okay? So you check this out, Loyola Marymount. So we have quite many different rules. Okay, let's finish it. So basically, if you have a D parentheses 10, that means that 10 digit. So this is a 1 followed by 10 digit. I think this one is like a phone number. Okay. So this is 2 to 9, and then 2 to 9. Or is or. So or means you have two different paths. Or 1, 2. 1, 2 is 102, so 102. Okay, followed by a digit. Okay. There's another OR, so OR 3 followed by 0 to 6. Okay, so this is the grammar for it, and then this means that the number from 2 to 36. Okay. Any number from 2 to 36 would use this regular expression. Okay, then actually contain some sub-pattern, 9-character string, okay, that start with MI and ending with FT. So means that you can use any letter in there. Okay. MI and then finish with FT, and inside you have 5 letters of any of your choice. Okay. Okay, and then backslash D means digit. Backslash capital D means non-digit. Backslash S means space. Backslash capital S means non-space. Okay. Backslash W means a letter. Backslash capital W means a non-letter. So these are very commonly used patterns as well. Okay. And if you have a beginning of a regular expression, you use a cap. Finish of the regular expression, you use a dollar sign. Okay. These are sometimes if you need to have a begin and finish one. Okay, so regular expression module is everywhere in the language. So right here after the basic grammar, here they do have a Java example, Perl example, Ruby example, Python example, JavaScript example. Okay, to talk about what are the use of it. So usually there is a match function. There may be a replace function, and there may be a search function or find function. Using the regular expression to do these different jobs. So they identify the patterns in your string, and then they would work on it to replace it or to match it. Okay. Any questions so far?
No.
So you can study this regular expression part. Okay. Next one. Where to verify your regular expression? There are many websites that you can do that. For example, here you have a Regit 101, okay? And you can look for the regular expression. So often use a regular expression like email address. Okay. So an email address usually have a regular expression of, let's see. I think this one is the regular expression for email. Let's copy it, okay? And put it right here. I'm sorry. So that is the regular expression, okay? This is a regular expression for email. So let's try this. Okay, so we do type something that's actually is an email, but some are not, okay? The regular expression say no matching. Oh, you all A to Z. Let me add it, okay? Add the lowercase letters. Okay, anyway, this email address. Let me try, okay, this one actually, let me try another one. Remember always no lowercase. Let me add the lowercase in, okay? Okay, so you find two match, okay? You find the matching information right here. You find two match in my examples, okay? So this regular expression 101 is to match where you have a regular expression. So that means that this is a valid regular expression for the email. For the email address. Is that okay so far?
Yeah.
So this one is a valid email address checker. So you can put the natural number or something in there as well, okay? So let me do this. Let me go to the directory that we have, okay? Let me pick up the regular expression. Okay, we'll save it and for later. So we are going to pick up this regular expression because we know it work. Okay, I'm going to pick up. Okay, this is the valid regular expression. So change line. We are going to go for this next one. Next one, if we have a regular expression for real numbers. So here, let's see. A regular expression for numbers. Okay, so here, like the natural number, I talked about it before. Okay, this is natural number. This is natural number. Okay. And then let's find something that more complicated. This is a fractional number. Okay. Fractional number. Let's don't use a backslash b. Let's use the cap and the dollar sign. Okay. That's the beginning and the ending of the regular expression. So let's copy this one. Put it into this one. Okay, now it becomes the number. Okay, so let's do 23.45. 2, 3, 4, 77. Okay. So right here, you see it matching 3 numbers. Is that okay so far? Okay. So this regular expression 101 is a Regis 101.com can do testing for you. Okay. Next one, what we would do is like, okay, how can our program run the regular expression? Okay. This is not enough. We don't always use the website to check your program with regular expression. So next one is how to have your program to check the regular expression. Okay. So first one is that let's look at this X. Okay, X. It has the regular expression replace regular expression match different functions. Okay. So you need to use the include the regis. Okay, you need to include the regis, and then you have a string. Then there's a match function. You can do regis that match the source and the regis pattern. Okay. So you declare a regis that would be a regular expression object, and you try to match these two. And if true is true, if it's not true, it's not true. Okay. Okay, so let's do this. Let's actually copy this program, okay? This one is called regular expression match. Let's copy this program and then modify, okay? This is called regular expression match function. So this one pretty simple, okay? Let's see, let's actually delete the unwanted letters. Okay, so basically, you include a regis, you have a string. Okay, let's change it. Okay, let's change it. This is string, let's assume that we have 2.45, 7.8, 999. Okay, the pattern, let's use the rational numbers pattern. Let's try this one. Okay. This one is a red one. We use a double slash as a single slash. It doesn't work here, okay? Because it actually is step sequence. So let's use a 2 slash as 1 slash, okay? Okay, now that's actually okay in the string. So we create a regular expression called B, and then we will match our source pattern against B, okay, against B. So this one you will say A match the expression or not, okay? So let's run it. Okay, there is no result because no matching. Okay, no matching because we are too greedy. We put a 3 pattern there. Let's actually reduce. Just drop down to 1 pattern. Okay. And run. So 1 pattern is show that there is a matching. Okay, A match B. So match function is to test your string against the pattern. Okay. Test your string against the pattern. So this one, if you use in the text processor, it's not very hard. You basically tokenize your word, and pass the word into the matching. Okay, pass the word with the regular expression matching. Okay. So let's see, let's try a different one. Okay. Let's try a different one. Let's try a program called matching numbers. I copy the matching program over. Put it into the matching numbers. Okay, so basically I'm going to delete the comments because we don't need it. Okay. Let's actually delete the comments. Here the regular expression patterns. So we do have a string, and then we are going to check how many number they are. Okay. So let's do this. Okay. So we do have a string, and then we would like to process the whole string. Okay, and then check if there is how many number they are. So in order to do that, we need to split the string, and then we actually will check against the regular expressions. So split function, we do it before. So let's try split by spaces, okay? So you can use a get line from the string and then T and then D1, okay? T is the tokens, DL is the delimiters, okay? So the program is you have a string and you have a string S, you have create a string using the str to create a string called SS, okay? So you have a string that actually is str. You put that into a buffer called SS, okay? And you create a vector called V. So you actually try to from your source, that's your buffers, to generate into the S buffer using space. And then if there is a later, you push into the space. Okay. And then you try to print it. So this one is the split function. Okay. This one is a split function. So let's copy this split function as well. So here, let's call this one for split. Okay, I copy into separate file because later you can verify each individual one. Okay, so this one is your split function. Let's delete those unneeded comments. We don't need that. Okay. So your source string is these, and you actually create a buffer that's called SS. Okay, and you will also have a vector that is the final vector you will have, and you will do get line. Okay, and then you push back into your buffer, and then you would print the vectors. Okay. So that's actually save and run. Okay, so this one separate them into the vectors. So now let's do one more thing. Let's actually put all of these into a function. Okay. So let's actually copy this one into another function. This function, let's call it SP2. Okay. So in SP2, we are going to write a function. The function would return vector of the string. Okay. And it can be modified, so let's return the alias. Okay, this one is called split. So this split would enter a string that you want to create. Okay, so this one is string, and then you will have the output. Okay, and you will have. Okay, let's don't return. Okay, let's use let's use a reference. So let's have a string of the pattern. The pattern, let's call it. The pattern, let's call it pattern. Okay. A separator, let's call it delimiter. Okay, delimiter. And then the result that we get is called vector of a string. And then you call it alias v. So v would be modified. Okay, so this whole thing that's actually copy them and put it over here. Okay. So this string let's actually cut it. Okay. Okay, this is split function. So basically, you don't need this. You don't need this. You generally need to prepare the input and output. Okay, so this one you will change it to split of your str and then a delimiter. So this one is called char. Okay. So right here, let's issue to delimiter. Okay, and you push into the vector v. So this will provide a separation using the space. Okay, and then eventually you'll print it. So this one make the split function into a function. Okay. Okay, so this one successfully split it. Now let's actually do this. That actually copy this split function into the matching numbers. So you do have a string A, then you would like to put into the vector of the string RV, okay? Okay. So here that's also called this one, okay? We also need a vector. We also need a string. Okay. So right here, you have this split function, so you are going to split your string A with the delimiter space, and then you will split into your vector V. Okay, so your V has everything that you need. Then you have the regular expression. So I'm going to create a counter for counter equals 0. Okay, then we will do for loop for integer I equals 0. I less than V the size. I increase. Okay, if the regular expression match of the V's I's number as a string against the V, then your counter will increase. Okay. So this one is matching numbers. So the extra of these, let's delete them. Okay. And then we do okay, this one will automatically count how many number in the string. Does that make sense? So here, if we put this is 5 doesn't match the real numbers. Okay, so let's try another one. Let's try 7. Let's try 7.44. Let's see. This local expression doesn't include integers. Okay. It only tests for real numbers. So 1, 2, 3, 4, 5, 6. How comes they are 7? Let me see out the size of V. Okay. There are 8 different ones. And there are 7 of them. The rule may be error. So this one minus sign, and then parentheses. Okay, let me check again. Okay. The problem is on this regular expression. Let me try real numbers. regular expression. Okay, let's just try this one, okay? I think this one is the easier. This one is the easier version, okay? Let's try this easier version. Oh, this one is wrong, that's why. So actually the regular expression is actually correct. I have a comma over there. That actually make an error, I'm sorry, but that's actually correct, okay? That actually verify that our regular expression and program is correct. Sorry for that, there's a bug here, originally it has a comma. So let's put a few comma there, let's see if it can be detected. So two error here, okay? That's right. Okay, so that can detect whether it's a regular expression or not. So okay.
Yeah.
So basically, you can do the matching, and there are more functions that you can do. There are also regular expression replace and regular expression find. You can find in the article or something. Right here, I'm just enter a line, but you can do line by line, several lines, okay, to use a regular expression to process it, okay. So this one provide two steps. First one is to tokenize using the separation of the space. Second, we actually tokenize it using the regular expression to verify whether they are numbers or not, okay? So basically, tokenization's purpose is to read in your text and then do proper processing of it, okay? So I think this is enough for regular expression. It's basically a front-end processing. Okay, we also show you how to do split. Okay, and there are more functions that you can use. They are also searching. Okay, so searching function, you have these. You are trying to find your A to Z. Okay, 0 or more. So they are trying to find the words. And after you finish, you put it into M. M is a vector. Matching list. Okay, it's a flag type. And R is the regular expression. So you search this against the peak of these. The output will find a word that's starting with geek. You will get this word. Okay. So let's try this one then. This actually is a matching word. All matching word will be collected over there. Okay. All matching word will be collected over there. So let's try this one now. I'm sorry. Let's look at this one. Look at this place and match. Okay, I'll delete. Okay, that's too low. So this one, let's call it matching words. Okay. Okay, so this one, let's actually change this. Okay. Okay, so we do have several numbers. Two are not correct. Okay, two are not correct. And then we would like to pick out all of the words. Those are matching. Okay. So I'm going to go back to my SP2. I'm going to my match numbers. I'm going to copy my string over. I'm sorry, not a string. I'm going to copy this local expression pattern over to the matching word. Okay. So this one I'm going to change it to R. Okay. So we have a source, we have a local expression, we have a matching list M. And then we are going to search the string against the local expression and then put them into the M. And M should show 2.45, 4, 9.9988, 2.33, and then 9.99 is 4, 34, 4, 22 should not appear. It can show. Let me save it one more time, okay? It's empty. Let me see out the M. Enter size 0. So actually it is successfully find. It is successful find. let's take out this starting and ending symbol. Okay, take out this starting and ending symbol. Okay, got it. So you got it, okay? So there are two. Maybe go for the next one. So this search will only find the first search, okay? You'll only find the first search, so that's not what we want. Okay, this one, I see, this one is not a good example. Let's try to use a find function for regular expression, okay? Okay, open to find all matches in regular expression in the string. Okay, I want this, actually I want this, okay? I want it to be in C double plus version. This is what I want, okay? Let's copy this version. I'm sorry, it's a mention number, let me redo it, okay, mention what, redo it. Let's delete it, okay? Okay, so basically the subject is what you have, okay? So let's put in the numbers. Put in these different numbers, okay? Okay, the regular expression R, let's use it. But let's use the numbers pattern that we had. Copy, put into the words, put it right here, okay? So change this to R and delete the one that they have. So we are going to check these against that, okay? So we actually do search and put it into the match object. The match object is string 0. This one is a number. Okay, this one is the object. This one is the object. This one match that 0. This one is the position number. Okay, so match the string 0. This one is the whole string. Okay, let's run this one. Still 0. let's don't use the star and end. Okay, sorry. Star and end means that you have to be the whole string match. Star and end means you need to have whole string match. Okay, so you do find these different numbers 2.45 at the position level, 4.58 position 1, 6.77, 2.33, okay, 5, 6.44, 7. Is that okay so far?
Yeah.
So you're searching on object against it, okay? The position level, I think, is actually the number from here. Is a space plus this, space plus this. So this is a number you probably need to have a spatial, I think it's actually finish this one, starting from here, you search for it. Finish this one, you starting from here, search for it. Start from here, you search for it. So you need to have a spatial counter to count it, to get the right position. Right here, it actually is not. It's 0, and then after that, everyone is 1, okay? Everyone is 1. So let's see, that's actually, we have a counter, right? And then let's see. So here, let's do this. Let's do integer position equal 0. Okay. So when you have a match, before we print out the position, okay. Before we print out the position, oh, you have a match, and then this one, position plus equals the match plus 0. And that would be your position. Okay. Okay. And then when you finish your position, it plus equal the match word plus 3, 0 as size. Let's see. Okay, so this one give you the right position. So let's see. This one tell you 2.45, 2.45 at location 0. Okay, so 4.58 at 5, 0, 1, 2, 3, 4, 5. Okay, and then 6.77, 6.77 is the position 10. So 5, 6, 7, 8, 9, 10. Is that okay?
Yeah.
So that actually this one, the position is the location of your words, okay? So you can use a vector to collect all of the locations. Then you know that where to find your real number location, okay, on the string, okay, on the string. And there are also sizes. you can record each word's size, right? This is each word's size. So you can save the position and the size of the word. Then you will know that where to chop a certain word out of the original string. Okay? Okay, so this is using the regular expression to search through your whole string or a whole file to find all of the matching words. Okay, to find all the matching words. Okay, so today we finish the regular expression, and then hope that next week we will do the infix and postfix processing. Okay, any question?
No.
So these different source code from website, I'll post it to you. Okay. So basically, regular expression is a very big topic. Because we do a lot of text processing in your AI or your program. So regular expression is some topic that you must learn. Okay, you must learn. And next week we'll talk about using the data structure to convert and evaluate the value from the pattern that you find. Okay. So this week we focus on the regular expression. We'll do topic by topic, okay? Every week we will have a topic and try to go through it. Loyola Marymount one is very important as well. Okay, play around the regular expression, and then next week we'll talk about the conversion of the expression and the evaluation. Okay, see you next time. Bye bye.